Okay.
Guess he needs to push it live.
Yep. Technical hiccups. Okay.
It's the first time, it's fine.
Yeah.
Oh, there it goes.
Okay.
Guess he needs to push it live.
Yep. Oh, and we are live. All right.
Right.
Well, hello everyone. So this is the first IMakeFOSS talk, and I am here with Kenneth Hoste, who has been our guest curator for the week. And we are going to be chatting about how he is involved with FOSS, and also some of the awesome projects that he is working on, especially EasyBuild and the Easy project. And we'll also be chatting about his some of the FOSDEM talks he's done and some of his tips for if you would like to give a talk at FOSDEM, what advice does he have? So Kenneth, it's great to have you here.
All right, thank you very much. I'm happy to be here. I'm happy to be part of this first IMakeFOSS stream. So I hope this will be fun for the people watching. I have a couple of slides prepared that I can walk through. Or you have any questions already, Monica?
Yeah, I would say, why don't you go through some of those slides and tell us kind of not only kind of how you got into FOSS, but what are some of the contributions that you've made, and how can we have fun with those?
Right, cool. So let me start with briefly introducing myself a bit more. So I'm a computer scientist from Belgium. I have a computer science degree from Ghent University, and since 2010 I've been working there as a HPC system administrator. So HPC is high performance computing. So we play with big supercomputers, like the one shown in the picture is one of our older systems. It's a relatively small one for being a supercomputer, but it's still fun to work with. And the main thing I do is I help the people who want to use these systems for their research. We give basic trainings for them. We help them out with software installations and all this kind of stuff. I'm a big fan of open source software. That's probably not a surprise since I'm here. I like a whole bunch of things. Yeah, I like a whole bunch of things, including my wife and my kids. Listening to loud music, beer, and yeah, FOSDEM is definitely one of the reasons there, and a whole bunch of other stuff. There's also stuff I don't like. Like, I'm not a big fan of C++ as a programming language. I haven't done a lot of programming in C++ myself, but whenever I need to install software that was programmed in C++, I often run into these big, ugly, cryptic compiler errors that take me forever to figure out. Maybe it's just me, but yeah, I don't like it.
Well, we'll know that if we get any thumbs down on this stream, it might be from the hardcore C++ fans.
Yeah, could be. I mentioned some other projects there as well, pretty much for the same reason. It's not because I don't like the tools itself, but whenever they give me trouble, so when something doesn't work when it's supposed to, any of those give me the hardest time figuring out what's going wrong in terms of getting them installed, getting them to work. And yeah, I've lost way too many hours of my life swearing at those. So that's why I mentioned them like this. You asked how I got involved with open source software. One of the big things there was attending FOSDEM for the first time, I think in 2013 must have been, so fairly recent actually. FOSDEM is a big open source. It's not a conference in the traditional sense. It's a meetup, which is held in Brussels every year. It's been there for well over 20 years, so for a very long time already, and it really exploded in terms of size. There's over the weekend they have 8,000 people there on 2 days. So it's really insane.
Yeah, I've
Um,
heard that the size is just like if you don't get to a room like an hour before, then it's a little tough.
yeah, and that's what they have, these full signs at the doors that they flip over if there's seats available. Most of the doors have the full sign on them. So if you really want to see a talk live, yeah, you have to appear well up front and maybe sit through another talk that you don't are not really interested in. Uh,
It's a good
and
idea.
one of the things at FOSDEM is people run around all the time. So it's not like you stay in the same room for the full
Mm-hmm.
day. You know, you go see a talk that you're interested in, and then you run out, or you actually squeeze yourself in between everybody else to try and get to the other room in time. And yeah, one of the cool things is there's beer at every corner. They have beer bars right next to the rooms where the presentations are. People buy a beer and walk into presentations and just are sipping beer while watching technical talks. It's a
Wow.
very special kind of meetup. Yeah. Once you've been there, I think you almost have to like it.
Yeah.
Um,
Well, hopefully, if not next year, then the year after, possibly.
yeah. So in 2021, they're going full virtual.
Mm-hmm.
No surprise there, I guess. So they're figuring that out now, how they're going to set that up, how they're going to organize it. That's a lot of work, of course, because they have to
Mm-hmm.
shift to a virtual setup in a short amount of time. But yeah, let's see how that works out.
Yeah.
They're trying to do more than just back-to-back talks. They want to
Mm-hmm.
replicate the hallway track a bit, so I think they'll try and have separate rooms per talk or something, and you can hang out there as long as you want. Talk to the
Yeah.
speaker.
Yeah, I know that that's been on Twitter. There's been some kind of good conversation this week about how do we make these virtual conferences better, and how do we make it so it's not just webinar after webinar. And I think that
Yeah,
especially the community tracks that have the social events and can recreate the hallway track experience have done really well. And so hopefully can kind of take what other conferences have been trying and kind of pick some of the best of those and put that into practice. So,
yeah,
but we might just have to bring our own beverages of choice, whether it's beer or tea or coffee. So
yeah, yeah.
we'll we'll
For
we'll,
me, for me
we'll
that
have
will
to
be
manage.
for me that will be easy. I have Belgian beer in my fridge all the time, so
Well,
for me it's not a
well,
big issue.
just for you, it's a slightly easier to come by. So,
Yes, yeah, exactly.
all
Uh,
right.
yeah, I want to mention this one as well. So this is one of the talks I have given myself at FOSDEM, which have been received very well actually. So this
Yeah.
was a bit of an experiment, and it's a sarcastic talk. So everything I'm explaining and talking about there is actually stuff you shouldn't be doing.
Mm-hmm.
Um, and I just figured it was fun to try and do a talk like this once, and people seem to really like it. And I noticed right before starting the stream that it managed to get 5,000 views on YouTube already, which is about how many people show up at FOSDEM on a single day. So it's like everybody who was at FOSDEM saw this talk, and
Yeah.
at least in terms of numbers. So that's pretty good.
Well,
I'm very happy with that.
hopefully it'll keep some package managers from crying. That would be
Yeah.
nice.
One of the funny things that has happened since I've given this talk is whenever somebody runs into something strange in terms of package management, like things you shouldn't be doing at all, people send me an email or tell me on Twitter, like, have you seen what they're doing here? And you should mention this in your next talk. I was running into something today, actually. I won't name the project, but the documentation of the project says if you want to install me, just use CMake and then make install. So that's pretty standard. But when I ran CMake, the first thing it says you don't have Conda installed. So they had a CMake file looking for a Conda installation tool, and then they were using CMake to drive Conda.
Oh my
And it's
gosh.
like it's these combinations of things that you just say, no, that's not how you're supposed to do it. You're just making it hard both on yourself and on others, and yeah, don't do that.
Well, it
Um,
seems like you've got the material for a sequel talk. So,
I by now I can probably do a full day talk on stuff like this. People have given me so many references and pointed out so many things to me. It's it's pretty insane. And the thing is that this talk grew out of a couple of years of frustration in getting software installed on the supercomputers that we support.
Yeah.
And I have a couple of cartoons here that I like to show when I talk about stuff like this. The funniest part about the cartoons is that it's not hard to find cartoons that match this story. So everybody has felt this pain. Like XKCD has 2 cartoons about it's taking forever for software to compile, or you have this install script that just tries a bunch of things and sees whatever works. And yeah, this what's it called, Geek and Poke cartoon. They say if you're the guy doing the build scripts, you're the most valuable person in the company, which is sort of true, right?
Yeah.
And the bottom one says, there's a lot of things like we're too busy trying to get things installed manually, and we're not really thinking about other possibilities.
Yeah.
So that's where, we had a different perspective about 10 years ago now in terms of tackling this problem. And that's when we started the EasyBuild project, which is one of the things I'm heavily involved with.
Yeah, I was just saying that this seems like a great chance to talk about your project, which makes that process a little less painful.
Yeah, so that's, well, it's actually not my project originally. I didn't start the project. When I started in the team in 2010, EasyBuild was already there as an in-house thing. It was nowhere near as clean or as big as it is now. So it was really in-house, and it was helping us in getting stuff installed. And the person who started it didn't have time to keep working on it, so he passed it on to me. It became my responsibility, and gradually we made it bigger, and we released it as open source in I think 2012. That was the first time we pushed it out in public. And what we were expecting was that we would get feedback from people on what we are doing wrong, or why we are not using this other tool that everybody else is using. And actually the exact opposite happened. So people found the tool, people went like, this cannot be true. If they have something like this, I want to use this. They tried it, and it worked well for them. And it just grew from there. It snowballed into a community around it, and before we knew it, we were having hackathons and a yearly user meeting and things like this. So there's hundreds of HPC sites around the world now using EasyBuild to install their software, and including currently the fastest European supercomputer, which is one in Jülich in Germany, installs all of their software with EasyBuild. So you have open source software running on a multi-million-dollar system, which is pretty cool.
That is pretty awesome. And it's just amazing that it's this kind of this organic community growth that has kind of helped kind of make that possible. And so so that just seems that's a really phenomenal thing. And so kind of if and we will definitely have some links, so if people want to kind of see what that community is about, then they will be able to join. What is maybe one of the things that you've enjoyed the most about being a part of that community?
Oh, it's just getting different perspectives on things, seeing how people use the tool in ways that you didn't imagine yourself, or they come up with features that you didn't think of yourself. We're getting contributions left and right. We hear about people who have been using the tool for years without us knowing it. So that's something typical in open source. People pick it up, try it, they go through your documentation, like it works for them. If it doesn't work, they try to fix things, and suddenly out of the blue, they send you a pull request. And they say, I've been using this for years, and I made this small change that I think could be useful for others. And it just, you hear about stories like this almost on a weekly basis. So that's very nice.
Yeah.
I've made several friends through the project as well. People who I never would be in touch with, otherwise. So you get to know people that, all around the world. Actually, some of them are probably watching now.
Hopefully, you can wave hi to all of them now.
Yeah, hi.
But it's, I think that's, there was a joke, I think, when I was doing the IMakeFOSS Twitter Twitter account this summer and talking about that, how we could really call this account We Make FOSS, because so much of it is the things that we're doing are almost always in concert with other people.
Oh
And
yeah.
and when you get just that magic combination of people with ideas and time and determination to make things happen, it's magic. And I mean, and that doesn't mean that it isn't hard and we don't have things like burnout and other kind of issues. But I think that's what makes it worth it to kind of, to struggle through those to get to that kind of alchemy
Yeah,
almost, which is pretty
yeah,
awesome.
it's really nice.
Yeah.
And I have a couple more things here
Okay.
that I want to make clear. So one of the important aspects of EasyBuild, which is a bit atypical from a regular installation tool, is that it's really focused on the performance of the installations you get. So we optimize the installations for the system on which they will be run, and that's a very important thing,
Mm,
especially in high performance computing. You have these big expensive computers that use the latest Intel processors or whatever else, and you want to make sure you get the best bang for your buck. And one thing that not enough people, I think, are actually aware of is that the way you install the software can have a huge impact on the performance of it. And it looks a bit sciencey and a bit technical, but what I was doing here is running a research application called GrowMax, which is something to simulate the behavior of molecules and things like this. So very sciencey, complex stuff. And what I was doing is I was running it on one of our computers that is part of our supercomputer, and I was just building it in different ways, compiling it in different ways. And if you're not careful, if you use a GrowMax installation that basically works on any Intel processor that you try to run it on, it'll work, but it will be pretty slow. So that's like the red bar here. It will simulate
yeah.
about 1 nanosecond of time per day. So if you're simulating for 24 hours, you have simulated 1 nanosecond of time of how molecules move. So the amount of compute that's behind this is insane. But if you recompile the same source code, so without changing any source code, you just give it different compilation options to the compiler, and you tell it compile it for this particular computer, this particular Intel processor, you get 70% speed up. So you go from about 1 nanosecond per day of simulation, you go to 1.85 nanoseconds per day. So you're almost doubling the amount of science you can get done in a given amount of time. And that's something that people don't think or maybe not aware enough of. That this is
Yeah.
a huge.
And especially considering some of the problems that these computers are tackling, then any kind of extra performance you get out of them is absolutely
Yeah,
vital. So,
this could mean the difference between discovering a vaccine or not, right?
hmm,
Being able to run something faster is not only nice, but you can get just more work done in the same amount of time, or you get the results faster. And actually, GrowMax is one of the software packages that is used in the COVID research. So
yeah,
they look at how drugs interact with molecules and how it can interact with viruses and things like this. So yeah, this is very important work, and the faster they can do it, the faster they get results.
yeah. And then the faster we get back to FOSDEM. So,
Yeah,
yeah,
yeah, exactly. Very important.
exactly.
Okay. So what we do with EasyBuild is we simplify the installation process of this software. Not only of GrowMax, and I'm mentioning TensorFlow here, which is something that people may have heard about. It's one of the most popular open source software packages out there that does this deep learning and machine learning, AI, so it plays in this space. But the way you install this thing from source is close to insane. the hoops you have to go through or to control how it is installed is very difficult. And what we did with EasyBuild is we basically simplified this to a single command. So you run the EB command, you give it this long string, which is the name of one of the files it has, and you go run it, and then EasyBuild will do this. It will step through it. It will start downloading the source files, unpacking them, applying patch files, configuring, building the actual software, and then go maybe run some tests, install it. So it has this whole series of things it runs through. And all you do is run EB and the command. You hit enter, you go for a run, you come back, and you have TensorFlow installed.
That's it.
Optimized for your system from source.
Nice.
If anyone who knows or has tried to install software from source, and then I don't mean pip install TensorFlow, that's very easy. But if you do pip install TensorFlow, you get the red bar in the graph. You get the version that works anywhere, and it could be pretty slow.
Yeah.
If you build it from source, which is way more difficult and it takes time as well, but that way you can get an installation that could be a lot faster. And for TensorFlow specifically, it's not really the case because they pull some tricks there. But in general, it's something you have to be aware of and take into account.
So that sounds really fantastic, especially kind of going back to that slide that you showed us previously, that if you want to get those optimized builds, then it takes the pain out. So, and I'm sure that there's some people watching going, I need this in my life. I really do. So, and so hopefully we'll get to show when we do that demo with the Pi, we'll get to show people how to put this into practice.
So this EasyBuild project has been going on for, if you start from when it started in-house, over 10 years. So this has slowly grown into something really, really big and really capable. So that's very nice. And we've come to a point where 10 years ago, when you told somebody, we're working on a tool that automates the installation of this particular scientific software package, they told you, I don't think this can be done. It's way too complex. There's way too many things you have to take into account. And we told them, we're doing it. And it's open source. So you can just download it from the web. You can try it if you don't believe us and see if it works for you.
Yeah.
And that's something I think that convinced many people. It was just out there and they could try it. And if it didn't work, they could let us know, or they could try to fix it themselves and then become part of the community behind it.
Yeah, I was just going to ask how many of those skeptics are now part of the EasyBuild community.
Some are, yeah. I remember in 2012 when we made it public for the first time. There's this big supercomputing conference, which is usually in the US every year. And we were there that year with our team. We were promoting the tool a bit there. We were asking people, how do you install software on your system? And we told them about EasyBuild. And most people had two questions. The first question was, how much does it cost? And we told them, well, nothing. It's open source. You can just download it and install it and start playing with it. You don't even have to tell us, right? You don't have to ask us permission or anything. So you can just try it. And the second question was, does it support OpenFOAM? OpenFOAM is one of the bigger scientific software applications that does computational fluid dynamics. So it does very complex simulations of how a gas flows through a volume or things like this. And it's also one of these things that's very difficult to install. People were literally spending days trying to get this thing to compile.
Oh, that's painful.
And when we told them, EasyBuild can do it with a push of the button, you just tell EB install OpenFOAM, they said, okay, now, you've convinced me, now I'm going to try it and see what happens.
That's awesome.
That's a lot of fun.
Yeah. And I would just like to say, so for the people in the chat, we are happy to have you here. And if you have questions or comments about any of this, please ask them in the chat. And we will make sure that Kenneth gets to give you his feedback. So for anyone wanting to know more about anything he brings up, please ask. So, all right.
And also afterwards, so I'm easy to find on Twitter, and you can jump into the EasyBuild Slack channel. if you have any questions there. If you try something and it doesn't work, let us know. We can only fix the bugs we know about.
So true.
So
All right.
maybe that brings us to another project, which is something that sort of grew out of the EasyBuild community. So this is the EaSSI project, and I have to thank my friend here who came up with this wonderful logo for it.
That is really nice.
Yeah, it's really nice. It has like science in it, and automation, and performance, and
data.
everything is in there. And he did a really nice job there. So the EaSSI project it's short for European Environment for Scientific Software Installations. And the main reason we named it like that is so we could name it EaSSI, which sounds like easy. Right? So EESSI, but you pronounce it like easy.
Having a good acronym, really, important.
Yeah. So it's a fairly new project. This basically got started last February. And actually, part of the reason why it started is it was a bunch of technical people who wanted to work together on something, and getting software installed was one of their major issues. Most of them were already using EasyBuild, and they said, okay, let's try and make something bigger, something better. What should we do? How can we do that? And so on. Part of the reason they did that was to have beers together, and then the whole COVID crisis happened, and since then we've been online, actually getting work done and not drinking any beers. But okay, we'll get to that point, hopefully.
Exactly.
This is a bit technical and looks a bit boring, but I'll give a demo of what this can do at the end. So what we want to do here is we want to build a set of software installations that you can just start using straight away. So not in the traditional sense of creating packages like RPMs that you install, but really just a stack of software that you can access at once, and you just pick the stuff you want to use, and everything magically works. So that's sort of the way. And it doesn't matter whether you're running on an HPC cluster, whether you're running on your laptop, or your beefy computer with the GPUs that you have, or whether you're running in Azure or AWS, so in cloud where you have VMs or stuff like this. It should just work. Whatever you use, it should work. Also, if you're running Linux or macOS or Windows, you should be able to access it. If you're running old CPUs, Intel CPUs, the latest AMD CPUs, or even ARM stuff or Raspberry Pis, you should still be able to use this. So it's a very ambitious idea, but we have all the parts that can make this work. And the nice thing is all of the things we have to rely on are open source software. So this is the different projects that are involved in the EaSSI project. So there's this CERN VMFS. So this is an open source project from the CERN Research Center in Switzerland, where they have the Large Hadron Collider, particle accelerator thing. This is what they use to distribute their software, because they have lots of scientific software that they use to analyze all the data that they get. They get terabytes of data per day, and they're spreading the work to analyze this data all over the world. And one of the issues they have is, if you need to analyze data, you need software. So they had to figure out a way to distribute the software. And that's what the CERN VMFS thing is about. They basically have one server that has all the software, and through this project, they distribute it to supercomputers, to laptops, to maybe even Raspberry Pis that analyze the data.
That's awesome.
So we rely on this as well we want to do something similar, but maybe a bit more ambitious than what they initially built it for. We're also using a Linux Gentoo. So Gentoo is a Linux distribution where you usually install stuff from source. So it's a good fit in an environment where performance is very important. So you can compile from a source. And this one we use to basically have a neutral ground where we build software on top of. So whether you're using Linux underneath or macOS underneath, Ubuntu, Fedora, whatever, you name it, we basically make a middle layer between that. And then when we install software on top of the Gentoo layer, no matter what's beneath it still magically works. So this is one of the other important components here, and then the ones in orange. So these three kind of work together. So EasyBuild I already mentioned.
Yep.
LMod is a tool that the concept is pretty simple, but you have to see it in action to really understand what it's doing. But it's a module. It's an environment modules tool. So what you can do with LMod is you can say, I want to use this version of TensorFlow, and I know it's there. I just want to activate it. I want to make it available to start using it. And it has all these. You basically have a TensorFlow installation. You have a tiny file next to it that describes how to activate the installation. And then you tell LMod, please activate this installation. That's the one I want to use. But one of the reasons this is needed on an HPC system is that you typically have multiple versions of the same software installed. You don't have one TensorFlow version, but you have a TensorFlow 1.13, 1.14, 2.1, 2.2, and so on. Because scientists, once they start using something, they don't want to have in-place updates and everything suddenly changes and they cannot trust their results anymore.
Yeah.
And you don't have just one software like TensorFlow, but you have we have over 1,000 different software applications installed on our supercomputer, and we have more users than we have software installations. But people have conflicting requirements. Some people are still stuck using Python 2, for example.
Oof.
Other people want to use the latest Python 3 and have all the fancy features and everything in between, right? So you need all these Python versions sitting next to each other side by side. And that's what a tool like LMod and environment modules, the concept behind environment modules allows you to do it. You just have different installations. You have an environment modules file sitting next to each of them that tells it to how to activate an installation. And then you tell LMod, please activate this for me. These are the things I want to use out of the 1,000 available installations.
Nice.
And I'll show this in the demo a little bit.
Excellent.
And then this Archpack thing in the middle here is a very small software package. It's basically a Python library which can detect what kind of CPU you have in your computer. So it's a very simple thing, but there was no good way detection is not very difficult. If you know a little bit about Linux, there's the proc CPU info file. You can just check and it will tell you what's there. But there was no good way to discriminate between families of CPUs. So you have different generations of Intel, for example. Intel Haswell, Intel Skylake, Intel, the ones I showed in the GROMACS plot earlier, which sort of is like generations of Core i5, Core i7, so it's a bit similar to that. And it's important to discriminate between those, because remember, when you're compiling software for a particular processor, you get better performance. Yeah. So if you can't recognize what kind of processor you have, then you cannot make a good choice between the installations, or at least you cannot do it automatically. You don't want the human to intervene.
Yeah, and it just seems that having the fewer hurdles for scientists using these computers as possible, then the more useful we are making them. So, and if it's if it's a simple tool that does that, then it's the best tool for the job.
One of the things is this is really very technical, right? If let's say you're a biologist or a chemist and you're doing simulations of molecules or DNA analysis, but then people tell you, you have to know which processor you're running on to get good performance. They're going to tell you, why do I care? Or why do I have to care? That's not the stuff I'm interested in. I'm interested in the molecules and the DNA analysis, and that's already difficult enough, right? They don't have to know everything about everything. Yeah. And with tools like this, you can basically abstract that away. You can make sure that you give them a software installation that works really well for whatever system they happen to run on. And they don't pay the price in slower performance. So yeah, I'll show a little bit in the demo as well how Archpack can help us. One thing next to detection of CPUs, it can also compare CPUs. So it can tell if you give it two things, it can tell which one is newer and which one is compatible with other ones and in what way. So it can, if you give it a binary, say for an Intel Haswell processor, it can tell you this will run on a newer processor, but it will not run on an older processor because it uses instructions that are not supported on older stuff. And that's also important. Yeah. And then the reframe thing is a testing tool. It's something, I guess you can compare it to something like PyTest, which runs a bunch of tests that you define. but it's built for HPC clusters. So for simulations that run across hundreds of nodes at the same time, where you want to keep an eye on performance. If you say, if I run this, it has to finish in 1 hour. If it takes 2 hours, something is very wrong. If it finishes faster, that's very suspicious, and I want to know about that as well. And Reframe knows all about this stuff as well. So that's another. We're not using it yet currently, but we definitely will in the EasyBuild project. And by pulling all these things together, then magic happens. And I'll show this with the demo. Just have one more slide here on Easy. So we have these different layers. The file system layer, which is the distribution of the software we have. So you have stuff in one place and you spread it across the globe by certain VMFS, so that everything is automated. You don't have to do anything manual yourself. With Gentoo, we make this middle layer, so we level the ground between the clients. No matter which Linux you're using, it should work. And then on the top, we build all the software with EasyBuild, all the scientific applications. And now, demo time.
Demo time. All right. And we also, yeah. And we also did have a question, though. Thankfully, one of our people in our chat also had some comments about the advantages of sticking with Python 2 over 3. So it's kind of over in the chat. So
there's no really, I wouldn't say there's any advantages. It's just that people are stuck to it. So they're using software that was written in Python 2. It's not compatible with Python 3. And they have a choice. Either they try to get a Python 2 installation somewhere so they can keep running, or they fix the code. And many of these people are just not able to fix the code. They've never written a line of Python, or maybe never programmed something themselves. I mean, these are scientists. They're not computer programmers. So all they care about is getting the software to run. And if they have to use Python 2 or even Python 1 for that, they'll just ask people, can you give me a Python 2 installation that still works, so I can get my science done.
Yeah.
So there's no advantage in sticking to old stuff. There's only disadvantages. It's probably slower. It's harder to get installed, certainly on newer systems as you go forward. So people should actively move to newer stuff.
Yeah.
But sometimes they're just not able to. Yeah. They don't have the experience.
So it just keeps the science going until they're able to make those updates.
Yeah, exactly.
All right. Well, I'm excited to see this demo. And once you get that terminal window open, I'll go ahead and make that full screen.
Okay. Let me try and find the terminal I want to share. Hold on. I think it's this one. Yeah. Let me make sure this is big enough.
Okay.
This is a blank terminal. This is not very exciting. What I want to show you is I have 4 Raspberry Pis sitting in my living room downstairs.
Nice.
Which I can talk to here over the network. So they are connected to the Wi-Fi. 4 different Raspberry Pis. It's a cluster, so they're connected together, like I showed on the picture. They can talk to each other. And the cluster is named Pichu. So that's the name of a Pokemon. We name our supercomputers after Pokemon. That's a funny detail.
Nice. Very nice.
And each of them gets a number. So Pichu 1, Pichu 2, Pichu 3, Pichu 4. And P- here is an open source tool that you can use to talk to different computers at the same time, ask them all the same question. So here I'm asking it, please run hostname, the hostname command on each of these hosts. So 1, 2, 4. And it just sends hostname to all of them. It gets an answer back, and that's the output you get. So what I want to do here is I want to log into one of them. So this is one of the 4 Raspberry Pis. I'll start a screen session here so I can log out again without interrupting the run. And here, let's say I want to do something sciencey. So it's basically an almost empty Raspberry Pi. There's nothing here. There's a 64-bit Linux running on it. So Raspberry Pi OS has a 64-bit version now. And the only other thing I installed was CVMFS. So let's see. I have CVMFS here, the latest version. So that's nice. Like the bottom layer of the Easy software stack. This was not very easy to do. I had to compile this from source because they don't have this package yet for Raspberry Pi operating system, 64-bit ARM. It's not really something they pay attention to, but once you get it to compile, it just works fine. So that's okay. So that's a very important aspect or very important tool for the Easy software stack. This is how we get access to it. So once CVMFS is there, once you have configured it and you've told it about the Easy repository we have, you can do this. So we have, and I hope it won't crash on me now.
Fingers crossed.
Yeah, so you have a /CVMFS part in your Linux file system, which is a special directory. And in there, you have different repositories. I think here I maybe have two. Yeah, I have this config thing. So that's where it stores configuration files for the Easy project. And I have this pilot repository, which has two directories in it, which are versions of our pilot repository. So the pilot repository is like the thing we're playing with in the Easy project to make sure we understand how we need to build this thing. We try to do a revision every month, so we're working on the November version.
Oh, wow.
And let's see what's in here. So this is a subdirectory. We can ls. So here we have the compatibility layer and the software layer. So again, just two separate directories. And another directory with an init, and this init has just a bash file that we can source, and this will set up the environment to start using the software.
Perfect.
Before I do that, let me show you what's in here. In compat, we have two subdirectories: one for ARM 64-bit, one for x86 64-bit. And in here, let's check the ARM one since we're on the Raspberry Pi. We have a Linux installation. So this is the Gentoo Linux packages. So this looks like a regular Linux installation, but it's in a very weird place. It's not at the slash like you would expect it to. It's in this subdirectory. This is why we use Gentoo, because it allows us to do this, to install Linux in a different place than it usually lives in.
Oh, nice.
So that's what we have here. And in the software subdirectory, we check here. We again have the same thing, ARM stuff and x86 stuff. Let me show the x86 one. Here we have three subdirectories: AMD processors, Intel processors, and then generic, which means any x86 processor. I don't care.
Okay.
So let's say Intel one. In here we have two types of Intel processors: Haswell, which is older, which is now about 6 years old, and Skylake is about 2 years old. And in here, in one of them, we actually have module files. So that's what LMOD talks about, or talks to, and actual software installations. And in here, then you have a collection of software. And
nice.
Things you'll notice here is OpenFOAM. So that's one I mentioned. TensorFlow is in here. GROMACS. This is the one we will be using, GROMACS. Let me show how that looks like. So in GROMACS, we have a version and some other junk which tells it how it was installed. So this is like a compiler toolchain, which compiler was used to install this GROMACS installation. And in here, we again have bin, include, and lib, so stuff that looks Linuxy. Mm-hmm. So in this place, we have like the GROMACS commands that are available and some of the libraries it needs to run and so on.
Nice.
This is basically what the file system layer provides, a bunch of software installations. But if you give this to a scientist, they go like, now what?
Their eyes might glaze over just a little bit.
Yeah, exactly. They don't really know what to do with this. So what we give them is a file, a script, basically, they can source. So sourcing is like executing, but it allows you to change the session you're in. It allows you to change the environment. So that's an important detail. If we source the script, magic happens. So it says, oh, you're using the Easy Pilot repository and this location. I've detected that you're running on an Arch, so an ARM 64-bit system. So this is a Raspberry Pi. And I'll use the generic installation because I don't have anything more specific for you. So I didn't show this for ARM. Let's show it here. There's a generic directory and a Graviton 2 directory. So Graviton 2 is processors they have in Amazon cloud, which are also ARM-based. So we have a separate installation for that because they are optimized for Graviton 2.
Nice.
Anything that's not optimized. So let me source it again. Well, let me scroll back. Source it again. It's fine. So it tells us, oh, you're on ARM64 bit, and I'll use the generic subdirectory because I don't have anything better for you. So this is what ArchSpec is doing. It does the CPU detection, and it also checks, okay, you're on a Raspberry Pi. Do I have something for Raspberry Pi? No. What's the best I can do? Okay, generic. That's the best I can do. So the bottom layer. And then here it also changes this module path variable. So it adds this location with this long path, which a human doesn't want to remember. It adds it to here. And this tells to Elmod, I have a bunch of module files for you here that you can use. So after doing that, we can ask Elmod. So Elmod has a module command. You can ask the module command which modules are available, and you can give it a keyword like GROMACS. So do you have something for GROMACS? And Elmod says, oh yes, I have this GROMACS installation here. And then it gives you some more information to search for, let's say, OpenFOAM. Okay, OpenFOAM is not here yet. That's my mistake. Let's say Python. Okay, so for Python, it says, oh, I have a Python 2.7.18 installation, a Python 3.8.2 installation, and something that looks like Python, but that's actually something else. So here we can already see that you have two different versions of the same software installed. And that's where the modules are helpful, because you can choose which one you activate. So again, for GROMACS, we have a module available, so we can load this and we can start playing around. Let me do that.
All right.
Okay, let me first do this. If I run gmx, so that's a GROMACS command, it's not there.
Yep.
So it's totally missing. That's annoying. But now when I load the GROMACS module, if I don't give it a version, it will just pick something. And since there's only one, there's not a lot to pick. I load the GROMACS module and then try to use the gmx command, and then it seems to find something. It takes a while because in the background what is actually going on, it's pulling down the GROMACS installation from a server which is actually in the Netherlands. So certain VMFS sees, you want to use this software installation, let me check if I have it. I don't have it yet. I talk to the server in the Netherlands, it pulls it down, and then it says, okay, now I have it, you can start running. And this gives us GROMACS. It looks a bit, it tells you a whole bunch of stuff. And now let's do something really cool.
Yes.
So we have this environment set up. I have a demo here. I have a demo for each 4 of these main applications that we currently have. Let's go to the GROMACS one. Has some files in here, some scripts in here. What I want to do is I have 4 Raspberry Pis. I want to use all 4 of them at the same time for running a single simulation. So I want to use GROMACS and I want to use all the compute power I have. So we're basically going to use these Raspberry Pis as a supercomputer. We're going to combine their power and to speed up the simulation to get more science done.
Yeah, I see that it's downscaled to 100 steps from 10K.
Yes.
Oh,
yeah.
Boy.
I had to because I want to show something that runs in a matter of minutes, and I only have Raspberry Pis, right? So these are Mickey Mouse computers. This 10K steps thing on the proper server, it runs in 5 minutes. If I would run this on the Raspberry Pi, it would take a couple of hours.
Yeah.
So that's why I scaled it down a bit. But the important part here is we're going to use this MPI run thing. So MPI is another open source. Well, it's actually a standard, and MPI is a standard, and you have different implementations of it. Most of them, not all of them, are open source software. What you can do is with MPI is you basically start the same software a number of times on different computers, and you tell each of these running programs, go talk to each other and agree on what you have to do. So they basically split up the work between them. They do each a bit of the work, and then they say, oh, I'm done, here's the result. And it basically converges back to one of them. So one of them is the boss, the main program. That's the one I will be starting here. And the other ones basically either ask what to do or decide by themselves what to do and tell the other guys what they're doing. So they basically distribute the work. So if I run this script, like this. So I'll just run it. This will start doing Gromaxy stuff. I don't know anything about the science behind this, so don't ask me
Oh,
that.
okay. So,
This is doing molecular dynamics. It takes a little while to actually start because, again, in the background, magic is happening. It's pulling down all the files that are missing to run this. And now let's see what this is doing. So if I run htop, so I just exited the screen session. If I run htop on this Raspberry Pi, it's computing. So you see these
It's
GMX, NPI. Yeah. So it has 4 cores. All 4 of them are busy. Let me log into one of the others. So Pichu 3. Have to be a little bit quick. If I run htop here, this guy is also running Chromax. It wasn't doing anything before. You can see by the load, it was idle before, and now it's actually running stuff. So all 4 of them are running Chromax, but I only started it really on the Pichu 1, and it was just telling the others.
Which was basically that boss one that told it, okay, guys, let's get to work.
Exactly. So, and it knows this because I basically told it, right? So I gave it this file pichus.txt, and this just has the name of all the nodes it can talk to.
Nice.
So the MPI command picks this up. It says, okay, I can talk to these guys and just spread the work. And in this case, let me go back to the screen session so we see it finishing. And in this way, this is fun to do with Raspberry Pis, but imagine doing this with 100,000 cores or thousands of servers. And in Ghent, we don't have systems of that size. The biggest one we have has about, I think, 11,000 cores now, which is our latest cluster, which is already pretty big.
Yeah.
But in the US and in Germany and France, they have supercomputers that are hundreds of thousands or even millions of cores. And they basically run simulations that use all of this stuff at the same time. So you can imagine the amount of impact that has if you're running big demanding simulations on these big things. So it looks like it's halfway now. It will finish in a couple of minutes, but you can do science on Raspberry Pis, right?
That is fantastic, and I just love that, and especially as someone who kind of started with kind of citizen science stuff with the SETI at home in, what was it, the early 2000s, then it's just, then kind of any of these projects are fantastic.
Yeah, and in some sense, with the EasyBuild project, we want to do something like what SETI was doing. So what they're doing there is they give you a program that you install, and you say you can configure it when it's allowed to compute, and then it pulls in stuff and it starts using it. It starts doing calculations. In some sense, that's something we want to do here, but on a scale of supercomputers and making sure we support both Intel processors and ARM stuff. And anything in between. So it's, I guess the idea is not new. Okay, it's done. So it seems to work.
I also like the Gromax messages there.
Yeah, it gives you funny quotes, and that's always fun to see. It gives you, this is from a band, Urban Dance Squad, but it does Simpsons things and movie quotes, and it does all kinds of stuff. And here you can see it was basically running. It's telling us 77 seconds, but that doesn't seem fully accurate. I think you have to multiply that by 2 at least. But it has been running calculations for 1,200 seconds. And that's because it was running on 16 cores in total, right? 4 Raspberry Pis, each with 4 cores. So it was getting lots of compute done by combining the power of all these things. Yeah. And to get a sense of scale, you can see here nanoseconds per day. It says 0.14. Remember the graph I had where it was 1.85 on a good system? Yeah, that tells you something about the compute power of Raspberry Pi. It's 10 times slower easily.
Yeah, they're trying, but well, we've got a question. Someone in the chat is asking, what happens if you want... Oh, I think they're talking about the... I think they're talking to someone in the chat about kind of this setup versus containers, and what is the advantage of this over containers?
That's actually a very good question. So for people who are not familiar with containers are basically a way of putting a bunch of software together in a box, and then you wherever you go, you take the box with you and you have the software that you need with you. There's a couple of problems with that. First of all, that box of software can be big. It can be gigabytes. When you're dealing with scientific software, it can be very big, or maybe you don't need one application, but multiple ones that you use in sequence. So you need a whole bunch of stuff at the same time. That's one thing. And copying gigabytes of files around to the cloud or on your laptop, or I mean, it gets out of hand pretty quickly. That's one small aspect. But the more important one is if you're running software, and remember the graph we showed for GROMACS, if you're running software, you better make sure it's properly optimized for the hardware you're going to run it on. Because if not, you'll get the red bar, right? You get the slow thing. It will probably work, but it will be a lot slower than it could be. And that's a trade-off that people make with containers. They package the software and they say, okay, I'm building a container. I want to make sure I can use this wherever I go. So I have to make the installations generic, right? I have to make them slow, not deliberately slow, but it's a side effect of making sure that it works everywhere. So sure, you have software in the container, you can take it anywhere, but it's probably going to be a lot slower than it could be. And that's one of the things we're fixing here, because we have basically separate installations per type of processor. We have magic in between that says, I will detect for you what your best match is. And the performance aspect of that is a lot better. There's another thing about container images. First of all, you have to construct one yourself. You need to figure out how to install software, and you're basically back to the same problem that I showed before with the magic script that tries all the things. Somebody needs to build that container image for you. It doesn't happen by magic.
If only, but we're not quite there yet.
Not quite there yet, but so that's one thing. Somebody has to build that container image, and maybe if you build it today, maybe a week from now, you notice, okay, I'm missing this one tool that I would actually also need. And that's when it becomes really, really tricky, because you have an existing container image and then you want to add stuff to it or replace stuff in it. You want to update something, you want to switch to a new GROMACS version because it can do science better, or whatever that means. So you have to start from scratch again. You have to rebuild that container image and so on. So all of that stuff is out the door when you use an environment like this, because somebody installs the software for you, and you can, since it's an open source project, you will be able to help out. You'll be able to tell us, like, there's a new GROMACS version and I want to push it in here, and you can help us out, and we're not there yet, but we will show you how to contribute software in here, how to get it built in here. And then it's available for the world, right? Anyone will be able to use GROMACS or any other software we have in here, as long as they have CVMFS working in some way. And it doesn't mean that containers are entirely useless, because we actually have a container ourselves in the EasyBuild project where we install CVMFS in. So if you have that container image with CVMFS, that's all you need to get access to all of this. You don't need anything else. So as long as you can run a container with Docker, or usually with Singularity on an HPC cluster, you're all set, and you can access all the scientific software that we include in our repository.
Yeah.
So
it's just kind of knowing that for this particular use case, that there are distinct advantages here. And I think that, this goes back to what you were saying, when these are computers that run you in the hundreds of millions of dollars and are solving helping to solve key issues in the world, then you don't really want a subpar performance there. So no.
Yeah, it could really impact the science you can get done. And COVID is the best example. People want to get this fixed fast, right? Not only good, but fast. And being able to get 70% speed up is massive. It's the difference between having a summer holiday or being stuck at home for another year.
Yeah.
So yeah.
And I love open source projects where that real world benefit is just so tangible to everyone. So that is really great. Oh my gosh, that hour went by so fast. But I want to make sure that for the people who have been in our chat, and you all have been awesome, and I love all kind of the conversations that you're having there. Are there any questions about either the EasyBuild or the Easy project, or getting involved with FOSS, or making your first talk proposal. That's a really
So
good.
to wrap up here, if people want to learn more about the Easy project, they can check out the links here. So we're easy to find on GitHub. We have a website. If you Google
It's a
us,
good
we're on
pun.
Twitter. So we're not very difficult to find.
Yep.
And actually, I'm giving a more in-depth talk about this project tomorrow at another stream thing. So tomorrow afternoon, 3 p.m. UTC. So people can Google for it, Easy and Source. So Source is an online series of research software events. So scientists, people who are both scientists and programmers working together and having like an online conference that has been going on for a couple of weeks or months actually. And yeah, I'll be presenting Easy there. And in terms of getting started in open source, attending FOSDEM is a very good way. And actually, the next FOSDEM is the best possible option you'll ever get because you don't have to travel. Everything will be virtual. So you can just hang out there. There will be like a dozen simultaneous streams going on during FOSDEM, going from web development to HPC stuff, desktop environments, anything in between, anything you can think about, it will be there. So just hang out there, see what you run into, see the people you run into, and you'll probably learn something and run into something interesting.
Yeah.
And other than that, yeah, just find a project that you're interested in. Try to reach out to the people behind it. Try to engage with the community. See what they need help with. See how you can get started. That's a very good way of getting started with open source.
Yeah, it just seems like finding that project that kind of speaks to your, not only to your passions, but to your skills is a great start. So, well, Kenneth, I want to thank you so much, and you have, and for anyone in the chat, if you have not read all the great things that he has been posting on the IMakeFOSS Twitter, you should go back and read those. We've really enjoyed having you as a curator and as our first YouTube streaming guest. So thank you.
Thank you very much for having me. This was a lot of fun.
All right, and just make sure if you have not subscribed to the channel, oh my gosh, hit that like and subscribe button. Press the bell so you will get notified of our next chat, and make sure to follow us at IMakeFOSS on Twitter. Thank you, everyone.
Thank you. Bye.